In section 12.3, we're going to be talking about probabilities with combinations. So first, let's define what a combination is. A combination is an arrangement of objects in which order is not important, as opposed to permutations from the last section where order was important. So for example, when we did permutations, if we were rearranging the letters A, B, and C, A, B, C would be a different outcome than C, B, A. But for combinations, they would be the same. It doesn't matter what order they come in, it would give you the same outcome. So for example, a combination would be like in a drawing for 3 identical prizes, the order of the winners would not be important because no matter what order they were drawn, they would get the same prize no matter what. So that would be a combination as opposed to a permutation. So here's an example. Count the combinations of 2 letters from the list of A, B, C, D, and E. So if it's a combination, it doesn't matter what order it is. So if I had A, B, that would be the same thing as B, A. So I could have A, B, A, C, A, D, and A, E. Then let's start with having B first. Well, we already had an A and a B, so I'm not going to do BA. So I could do BC, BD, and BE. So let's move on to C. We already had an A and a C. We already had a C and a B, so we're going to start with CD and CE. And then finally, let's start with D. I already have an A and a D, a B and a D, and a C and a D, so my only combination for that would be a D and an E. So I would have 4, 7, 9, 10 combinations. Just like with permutations, we have formulas we can use to find the number of combinations in a given situation. So the formula is, if you have n objects taken r at a time, where r is less than or equal to n, so basically this number has to be smaller or equal to this number. It is given by NCR, which is equal to n factorial, so your first number factorial, divided by the 2 numbers subtracted, so n minus r factorial, times your last number factorial. So for example, if I am taking 4 objects taken 2 at a time, it'd be 4C2, so I put 4 factorial on top, divided by the 2 numbers subtracted, so 4 minus 2 factorial, times the last number factorial. So we have times 2 factorial. So 4 times 3 times 2 factorial, we left that as 2 factorial because that would cancel with the 2 factorial that we got when we took 4 minus 2, times 2 factorial is basically just 2 times 1, which is 2. So you end up with 4 times 3 is 12, divided by 2, so you get 6. So let's see an example of doing a combination. So here's example number 2. It says you choose 2 courses out of a list of 6. How many combinations of electives are possible? So we're using a combination in this problem because order wouldn't matter. If I choose a math course and a history course, that'd be the same thing as choosing a history course and a math course. So again, order doesn't matter, so we're using a combination. We have 6 possibilities, and we're taking 2 at a time, so 6C2. According to the formula, you take the first number, so 6 factorial, over, subtract the 2 numbers, so 6 minus 2 factorial, times the last number factorial. So simplifying, I end up with 6 factorial on top. 6 minus 2 is 4, so 4 factorial times 2 factorial. And then I can reduce this a little bit. So I'm going to write this as 6 times 5 times 4, and then factorial, because I have a 4 factorial on the bottom that I can cancel with that 4 factorial on the top. So again, this 4 factorial would cancel with the 4 factorial down here. So 6 times 5 is 30, and 2 factorial is equal to just 2. So 30 divided by 2 is 15. So that means that if I had a list of 6 classes, and I'm going to take 2 of them at a time, I would have 15 different combinations of picking 2 of those 6 classes. Let's look at our last example, number 3. Your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the press in high school newspapers. What is the probability that your teacher chooses you and your best friend? Before we get into the probability part of this problem, let's talk about why we're going to use a combination as opposed to a permutation in this problem. It says the teacher is going to randomly choose 2 out of 18 students. So it wouldn't matter if they chose me and my best friend or my best friend and then me, because either way we're both going to do it. So it's going to be a combination because the order would not matter. So back to the probability part of this problem. Remember, probability is the total number of favorable outcomes on top divided by the total number of possible outcomes on the bottom. So let's figure out the number of possible outcomes first. So again, we're going to use a combination because order does not matter. There are 18 students and 2 are chosen at a time. So that would be 18 factorial, according to the formula, over 18 minus 2 factorial times 2 factorial. So again, I'm going to reduce that and get 18 factorial over 16 factorial times 2 factorial. So I'll reduce that and do 18 times 17 times 16 factorial. I'm going to go just as far as 16 factorial, knowing that I'll end up canceling with the 16 factorial on the bottom. So I'm going to do that. So I end up with 18 times 17 over 2 times 1, which is equal to 306 over 2, which is 153. So there are 153 possible outcomes of the teacher choosing 2 out of the 18 students. So that's going to be the number on the bottom for our probability. So let's set up our probability. So remember, it's P of you and your best friend getting chosen randomly out of the 18 students would be equal to, and again, the total possible outcomes goes on the bottom. Let's think about the favorable outcomes. There would only be one way out of all the possible ways for your teacher to choose you and your best friend. So our favorable outcomes would just be 1. So we're going to take 1 divided by 153 in our calculator and then move the decimal point 2 places to the right to get it as a percent to get about a 0.65% chance that you and your best friend will be chosen randomly to give the debate on the freedom of press in high school newspapers if there are 18 people in your class. That's it for this section. Make sure you jot down anything you don't understand that we can cover in class before we move on, and we'll see you then.